Hello everyone, today is day 20 of solving a LeetCode problem every day. So today I'm going to be solving car fleet. So there are n cars at given miles away from each other. Let me reread that. There are n cars at given miles away from the starting mile 0, traveling to reach the mile target. You're given two integer arrays, position and speed, both of length n, where position I is the starting mile of the ith car, and speed I is the speed of the ith car in miles per hour. A car cannot pass another car, but it can catch up and then travel next to it at the speed of the slower car. Now one quick point is that it says a car can catch up to another car, but then it must travel at the speed of the slower car. If a car catches up to another car, the slower car is always going to be the car in front. That's just a point I want to make real quick, because I think it's going to be important to know that when you solve this problem. Next, a car fleet is a car or cars driving next to each other. The speed of the car fleet is the minimum speed of any car in the fleet. So like I said again, the minimum speed is always going to be whichever car is in the furthest position or started out in the furthest position. If a car catches up to a car fleet at the mile target, it will still be considered as part of the car fleet and then return the number of car fleets that will arrive at the destination. So in this case, the output is 3 because the car that starts at 10 and 8, they intersect at 12. The car starting at 0 doesn't catch up to any car, so it's a fleet by itself. And then the cars at position 5 and 3 become a fleet because they intersect at 6. So the way you can kind of think about this problem is it's kind of like a number line. So I'm just going to copy this out here. So with this specific test case, 10, 8, 0, 5, and 3, so this example one right here, you can look at this as kind of a sorted array of tuples where it's sorted based on the position that it's currently at. Now, instead of thinking about it in terms of like when are these cars gonna meet up, you can think about it in terms of how many iterations is it gonna take for one of these cars to reach the target. And the way you can calculate that is, for example, in this case, our target is 12. So let's say that our target is 12. To figure out how long it's gonna take, for example, this car right here. So the speed of this car is 2. The position of that car is 10. The amount of iterations it's gonna take, or the amount of time that it's gonna take for this car to reach the target position, which is 12, is just equal to 12 minus 2 divided by, 12 minus 10 divided by 2. Sorry, I was messing up my algebra a little bit, but the way you can think about this is you start at position 10, and then how many times do you move 2 places to reach the target 12? So I mean, if you manipulate this expression right here, you would get 2x is equal to 12 minus 10. So then 2x is equal to 2, and then it would be x is equal to 2 divided by 2, which is equal to 1. So you know it pretty much takes one step or one iteration, or I guess you can say 1 second or whatever it is, to reach to this position 12. Now here's the second point that I want to make. If we have 2 cars, and let's say we have the car that starts at position 8. Let me zoom into this too. So let's say we have a car and it starts at position 8, and we have a car that starts at position 10. If it takes 1 second for this car at position 10 to reach the target, and then it takes 2 seconds for this previous car to reach the target, what we can automatically say is that there's no way that these cars become a fleet or intersect, because it takes more time for this car to reach the end than it does for this car to reach the end. But now let's say that this car up here takes half a second to reach the end, and this car takes 1 second to reach the end. This car must at some point intersect with this car to go to the end, because it says here that it takes 0.5 seconds to reach the 12, and this takes 1 second to reach the 12. So that means that at some point this car must pass this car. But from the question, it already told us the cars can't pass each other. They can only become a fleet. So what's going to happen is that these two cars get grouped into a fleet, and they move at the speed of the car that's in front of it. So at the car 10. So I just wanted to kind of explain that a little bit because I think it's going to help make more sense of the code. So this is kind of how I started. I first started by creating this array of pairs that I have over here, and I sorted them so they're in sorted order. So this is the first car, second car, third car, fourth car, and fifth car, and none of these previous cars can pass any car that's in front of it. So this car can't pass this one, this car can't pass this one. Once I did that, I appended basically the amount of steps that it would take into a steps array. So I would go through each of these pairs and then do the earlier calculation that I showed to come up with how many steps it would take. So for example, in this case, the target is 12, the position is 0, so 12 minus 0 is 0. So basically how many steps is this car going to take to reach the end? It's going to take 12 steps. And we append that all to an array. And then we initialize a groups variable that we are going to output. So this is going to be how many fleets there are. And then while this steps array is not empty, we're going to grab the very last element in this array. So it's going to be this one. And we're going to add 1 to the group, pretty much indicating that we're calculating this specific fleet. And now while steps and step -1 is less than or equal to popped. So first of all, we check if steps is not empty. And if it's not empty, then we check if the end of this steps array is less than or equal to the value that we just popped. So for example, in this case, popped would be equal to 1. Groupings is now equal to 1. And the very last element is not going to be 1 anymore. Well, it's still going to be 1, but not this specific one. Now we check if this last element is less than or equal to the element we just popped, which is true. So this means that they must intersect at some point because they both reach after 1 step. So that means they intersect at the very end. So in that case, we just pop this from the steps array because we're going to consider this as one group since we already know that they have to intersect. So they're one fleet. And now we compare 7 with 1 and we see that 7 is not less than 1. That means that this specific car right here is gonna reach the target after the earlier fleet, which is the one with the both 1s. So we can start a new iteration now. So popped becomes 7, and we can pop this off. And now we check, so while steps is not empty, we can keep going. The end of steps is 3. So while 3 is less than or equal to popped, which is 7, so that is a true statement, we want to pop. And the reason we're popping again is because it takes 3 steps to get to the 7. Or it takes 3 steps to get to the target, which is 12. But here it takes 7 steps to get to the target, which is 12. So we know that at some point, this car right here must intersect with this car, and they move at the speed of this car. So we can pop this one, and we also set groups to be 2 now, because we increment it over here. And we know that those 2 are a grouping. But now we check the last one takes 12 steps to get to the target, which is 12. But this one this fleet is taking 7 steps to get to the target, which is 12. So we know that they don't intersect because this fleet is going to reach before this fleet. So now we can do our last iteration, set groups to be 3. And we set popped to be 12. The steps array is now empty. So in this case, we can just finally return groups, which is 3. So I hope that this solution kind of makes sense. I know, it's honestly, this problem honestly took me a little bit to solve, but like once you figure out the trick to it, um, it's honestly pretty intuitive. It makes a lot of sense. One thing that I will say is that if you're struggling with this problem, would be to draw yourself a graph where the x-axis is going to be position and the y-axis is time, and you can kind of draw a function out for each of these cars with their starting position being like whatever their starting position be, and then you can kind of draw like what position it ends up depending on how many iterations or how much time it has been. And that will kind of show you how all the fleet intersections happen, and I think the problem makes a lot more sense once you draw it out for yourself. So the time complexity of this is going to be let's see, it's going to be n log n. And the reason why it's n log n is because the sorting algorithm is already n log n. And here, this is n operations. And here, this is another n operations. So at the end, it just becomes n log n, time complexity. Now, as for space complexity, let's see. So let's see how much extra space we use. So first of all, we have this pairs array that we create. This is just going to be n items. And then we have another steps array that we create, and this is another n items. And other than that, we don't really use any extra space. So the space complexity is also just going to be linear. So yeah, that's my solution for the day.